So a very warm welcome to all of you on behalf of Azim Premji University. We are delighted to present today's program in our series of public lectures which are held at our two campus cities here in Bangalore and Bhopal every month. Public lectures are one of the ways by which the Azim Premji Foundation promotes its vision. All our public lectures, close to 100 so far, are available on our YouTube channel, and I invite you to view them. I know you come to our public lectures because you are well-wishers of Azim Premji University and invested in the education and development of the country. Thank you all. A brief introduction to the speaker, the interlocutor, and the topic. About the speaker first. Professor Vijay Raghavan's CV was part of the invitation, so I'll only pick the highlights. Vijay Raghavan is the Homi Bhabha Chair at the National Center for Biological Sciences. He has previously served as the Principal Scientific Advisor to the Government of India, some of it during the crucial COVID years. Professor Vijay Raghavan continues to be involved in science, technology, and innovation in all sectors while pursuing his research in his laboratory here in Bangalore. Several honors have come his way. He was elected a Fellow of the Royal Society, and I'll just make a short detour here. We have another member of the FRS in the audience here, and we are privileged to have you with us, Dame Wendy Hall. And so there are two people here today in the audience who have signed in the same register as Sir Isaac Newton did. Professor Vijay Raghavan is also a foreign associate of the US National Academy of Sciences. He was conferred the Padma Shri in 2013, and he is a recipient of the Infosys Prize in the Life Sciences category in 2009. Please join me in welcoming Professor Vijay Raghavan.
Thank you very much, Sudesh, and it's a great pleasure and an honor to be here today. And I'm very much looking forward to interacting after the talk in the panel discussion too. One of the dangers in a topic such as what I've given is that there is a good chance, and I see that unfortunately happened, unfortunately for me, that there are more experts on this side than on this side on everything I'm going to talk about. And so that means that, I probably will make errors of various kinds in what I say, but still, I think the broad purpose of what I want to convey remains, and that'll be something interesting for us to talk about. And that purpose is the following. For thousands of years, people have predicted doom of various kinds. And human innovation seems to have constantly gone, circumvented those problems or leapt over those kinds of problems. How to feed people, how to survive disease, and so on and so forth. Yet, today's world, many argue, is different, that we are going through a tumultuous period, and the multiple challenges posed by climate change, environmental degradation, problems of sustainable development, huge migrations, political turmoil, wars, all of them are such that it has pushed us to a precipice. And it's not clear to many people that the solutions and the ingenuity which pulled us through as a human population through our previous challenges will work this time. There's another school which thinks that no, these are tough times indeed, but solutions are always there, and we'll find a way out. While these are discussed over the last few years particularly, the looming challenge posed by tech giants and artificial intelligence and the possibility of artificial general intelligence has entered debate in new ways. And what does that mean? Does that mean that something new, some other way of looking at the world is going to happen, or is it going to be more of the same, or is it mere hype? So these are the kinds of questions which are posed for people all over the world. Well, posed for some people, but if you step out of this building and walk down the street and ask someone where climate change or the threat of AI stands in the top 10 lists of problems they have, these will probably figure at number 200 or 300 in the list of their problems. They're interested in getting a job, feeding mouths, dealing with family issues, getting kids to school, and so on and so forth. And for that, our structures are grappling with in any case. Do they need a new way of looking at this, or will business as usual in those structures be fine? And that too we don't know. So how do we make these kinds of issues clear and understandable to our communities in a way which, if they are going to impact these communities, then there are solutions also which are acceptable to communities which come about. And that poses a huge challenge. Otherwise, you're going to see multiple kinds of alienation already upon us, the alienation between extreme haves and others who have not, tech giants and others, and so on and so forth. And a lot of this causes, again, tumult in democracies by having extreme polarization. Okay, so let's get started. The world is in turmoil, and this turmoil was something which we saw coming a long time back. And much of it started about 10,000 years ago when humans started domesticating plants and animals and living in communities. This changed us in dramatic ways. Language became sophisticated. There was creativity, abstraction, the making of tools, and human societies started growing in multiple ways. Yet, there was a great danger to those societies that they would run out of food, for example, and as they developed agriculture, they started looking for fertilizer to renew soil. Otherwise, agriculture by burning forests, growing and moving on, was not feasible for a growing population. And humans also, by that time, had of course invented fire and the ability to cook food and have concentrated calorific content, high protein diet, also required, with the domestication of livestock, the scaling up of livestock production. So fertilizers became accessible through, bird guano. And as Europe developed much later, not 10,000 years ago, but early 19th, 17th, 18th centuries, bird guano became a fertilizer to grow agriculture in big ways in those societies, in European societies. That ran out, and then mines in Peru and in China provided phosphate fertilizers, and that started running out. Until in the early 20th century, two German scientists, Haber and Bosch, pulled nitrogen out of the atmosphere and through what is now known as the Haber-Bosch process, made ammonia. And that allowed the making, on one side, of ammonical fertilizers, which allowed people to break out from limits of population growth because food became abundant. And on the other side, allowed the creation of chemical weapons, which symbolized the dual use to which science could be put. And this has been the perennial challenge of science, innovation of all kinds, which has allowed humans to survive against all odds, but at the same time causing devastation in multiple ways. And it's not science per se which causes this. It is our politics, our society, our economics, our culture, which all uses science and technologies in these interesting ways, with scientists, of course, being part of the whole ecosystem. So let's first go through, and by the way, the introduction said I'll talk about Indian science first, but I've moved that to a latter part of my talk. I'll first summarize how the world has changed in terms of climate and environment, and then talk about how new technologies have come about, and then finally end by talking about how Indian science shaped over the last, from the beginning of the 20th century, how well poised it is or not to deal with the kinds of future we are heading to. This is Earth's temperature, and the mean temperature above the baseline shown, the flat baseline shown, has been going up steadily over the past several decades. For example, the rate of warming since 1982 is more than 3 times as fast as earlier, and it's about 0.2 degrees Celsius per decade. 2023 was the warmest year since global records began in 1850, and that too by a wide margin. And it was about 1.18 Celsius above the 20th century average of 13.9 degrees Celsius. So the 10 warmest years in the historical record have all occurred in the past decade. So this is something which is quite stunning. And the way Earth's surface temperature is measured by multiple parameters over a long time is pretty amazing, and that's another talk about how science can make these kinds of measurements and give us these facts for us to see and then to decide what's happening. Now that's also true about, another aspect is about global sea level rise. And that's again going up. And if you look at the predictions which were made around 1990, and you go through some videos, Al Gore, for example, and several others, they talk about how in 2010, there's going to be disasters of all kinds. And people today point out, my God, that video said that this kind of a disaster is going to take place, and it didn't happen. So there are examples of predictions which are more severe, but if you go through the actual data, you see that they covered a wide range, and the current situation was sea level rise, for example, which is about 8 to 9 inches, that's about 21 to 24 centimeters, since 1880 is rather substantial. And in 2023, the global average sea level set a new record high of 101.4 millimeters above 1993 level. So this is a problem, and sea level rises vary across the world for a variety of reasons, and the rate of global sea level rise is accelerating and is more than doubled per year throughout most of the 20th century, up to about 0.14 inches per year from 2006 to about 2015. So sea level rise is going to be a big problem going forward. Is going to be a big problem in our eastern areas, particularly in Bangladesh, but also in the West Coast. It's going to be a severe problem for the Pacific Island countries. And the question is, what can we do about it? And that's something I'll come to. In addition to that, these rising sea levels and extreme flood events, which we have seen all over Europe and America recently, parts of India regularly, whether or not they are attributed to climate change are a very serious practical issue, and it's clear that the frequency suggests that many of them can be attributed to climate change. Much of our urbanization and our growth of cities has taken place in a manner which has not taken into consideration these aspects. Construction has taken place hugely in attractive seafront areas or on riverbeds, and that's caused the kinds of floods and problems which we see regularly today in India, in Europe, in America, parts of China recently. So this is a big challenge on how to deal with urbanization, the growth of cities, and then finally, how does that lead to either mitigation or adaptation in our policies. Another aspect, and this was starkly seen more recently in the west coast of America, and there in the Los Angeles area, and this picture is from an earlier one, again from that area. Changing climatic conditions result in new wind patterns. That combined with dry heat can dry up grasslands very rapidly. And a mixture of that and unseasonal rains result in more grassland which dries up, all ready for a spark to trigger huge fires. And this keeps happening periodically. And this is something which is difficult to predict where it will happen and when it will happen. People are often criticized for not being prepared for such events. You can be prepared for something which is 10%, 20%, 30% more than what your capacity is, but when something happens which is threefold or fourfold your capacity, then there's a big challenge. And this is going to happen with greater frequency. If there's one part of India which is extremely vulnerable, and a part which is very critical for all of India, and indeed all of monsoon patterns and pretty much all the world, and that's the Himalayas. The Himalayas feed in water to the Bay of Bengal, and that is a very big factor for sustainability of ocean ecosystems. And changing snow melting patterns, deforestation, and glacial bursts have resulted in many huge disasters. That, combined with human populations which want greater access, greater energy from hydroelectric power, all of that pose difficult contradictions to resolve, and that results in a situation where disasters of this kind, as in Uttarakhand, are likely to keep happening. In all this, the big challenge which people at large face is what I said at the beginning, which is people want to, A, get out of poverty, and then, when they manage to do that, fulfill their aspirations. There's a tendency in global development discussions to talk about how we need to take people out of poverty as if good nutrition, good food, shelter, primary education, good primary health are sufficient for a good life. Whereas those who talk about these see a good life as meeting their other aspirations, which involve their intellectual pursuits in music, in sport, in science, and literature, and so on. If those pursuits are also to be available to people at large, we have a big challenge. We address principally, globally, the requirement to take people out of abject poverty, and that's of course very important and necessary, and that's likely to be happening. But coming out of that abject poverty and living in conditions where your social, cultural, and intellectual aspirations are not met are also a very, very big challenge. So this is the situation the world is in, or at least was until a few years ago, or at least last year, when rather dramatic political changes in America and the culmination of changes or the peaking of changes happening in Europe have turned everything upside down. For a long time, there was this view that Western countries, Europe, America in particular, had the good of the planet in mind when talking about energy protocols, about sustainable development, reducing fossil fuels, and so on. And these were absolute goals whose reaching we must all work towards. And this is something very important for the planet. In other words, a planetary goal, a common goal, was an ideal put forth by these groups. And all of a sudden, that seems to be flipped by a statement, drill, baby, drill. And we are now in a position where we are supposed to look after each of our national interests, right? What does it mean for common goods? Suddenly we have an enormous challenge, enormous tragedy of the commons. And that is fundamentally what we face today. How do we deal with public good in a situation where there's great pressure, understandably, for development, sustainable development and growth from the perspective of large communities which feel left out and say, left out of development, out of jobs, and they want these things first. And to them, all of these other global issues can be dealt with later. Let me go back to how we came to this situation and then talk about how we can potentially deal with this from an Indian perspective. How did we get here? And we have a rather peculiar situation. I mentioned about our state 10,000 years ago. 10,000 years ago, humans, our pets and our livestock constituted 0.1% of terrestrial vertebrate biomass. So cows, dogs, monkeys, donkeys, us, were 0.1% of vertebrate biomass, lions, tigers, and so on. Today, humans, our pets, and our livestock constitute 98% of vertebrate biomass, right? Most of them are chicken. So how did this come about? We were a species whose entire focus, our ancestors, this is from the movie 2001, A Space Odyssey, our ancestors, not this one, were intent, as all other organisms on Earth, intent on survival and nothing else. That's what mattered. Then something absolutely stunning happened to us as distinct from other organisms on Earth. Other organisms grew in different ways. Our primate ancestors grew in ways very similar to us. But our brain size is substantially larger for a body weight, for a body size, than that of other primates. We have been able to eat high-calorie food in such a manner that allowed our brain to grow, and fortuitously that allowed the brain to be a massively parallel supercomputer which is over-designed for just survival. It can do lots of other things. That combined with mechanical engineering, our ability to speak and articulate, our ability to oppose thumb and forefinger and make objects and throw, make instruments, changed not only us and our communities, but changed the world. We moved from being mere survivors on the canvas of Earth to those who wield the paintbrush. The entire future of the planet now depends on us. In 2001, Arthur Clarke imagined some extraterrestrial object coming in and converting this ape brain into what is now a human brain by injecting some kind of a software. But that's not what happened at all. But what happened is something very similar. The hardware of our brain is exactly the same as it was before, well before 10,000 years ago. But 10,000 years onwards, and particularly for a few thousand years from now, we started getting better and better at software development using the same hardware, and therefore we evolved enormously rapidly culturally while our biological evolution didn't take place at any significant rate. So the memes we transmit, the ideas we transmit, the abstractions we are capable of has transformed us, the way of thinking, and the planet as a whole. And this is rather dramatic. No other organism on Earth is able to make a telescope, send it out to space, and find out how galaxies are made. Now, that's a very strange thing. Maybe there are other such organisms elsewhere in the universe. We don't know. It's quite possible they're there. But these are strange pursuits, and they're not the pursuits of organisms which are used to merely survive. These are non-survival based pursuits. And therefore, when this organism is threatened with survival, it also has the capacity to completely ignore that. Humans are very strange in that they're the only organism, perhaps, which can contemplate the idea of death and destruction and elimination. But we are also the only organism, perhaps, who can, after contemplating all of that, say, nope, I'm not going to look up, everything is fine. So this is the James Webb Telescope, absolutely stunning. And just that there are huge advances in manufacturing, in space technology, in nuclear power, and all sorts of chemistries and physics, there have also been enormous changes in biology. In trying to understand nature's engineering, what happens all around us in geology and biology and ocean science and climate science and so on and so forth, we've also become engineers of nature. extraordinary, and by delving deeper and deeper into understanding biology, we are capable of extraordinary biology right now. Synthetic biology is very powerful, but also, like artificial intelligence, poses both enormous opportunities and potential pitfalls and threats. So that's another area to look at. What happened at the start of the Industrial Revolution was something interesting. It was focused rather substantially on manufacturing, the development of products which were marketable, and rather primitive computing methods which in no way, they seem extraordinary from today's perspective. But the ideas for how computing could take place started developing rather early. In the 20th century, mathematics, linear algebra, statistics, looking at vector spaces, all of that was again an extraordinary tribute to human abstraction, which the practitioners at that time didn't particularly see as applicable. Some aspects of statistics, of course, were hugely used, but other aspects were very, very abstract. During the Second World War, computers, typically humans, were involved in breaking the Nazi code. They were very important in ending aspects of the war rather earlier. And one of the most famous people involved in those efforts was Alan Turing. And Alan Turing, as many of you here know extremely well, came up with the ideas of the Turing test to check whether any of you are actually machines or not, and also about computing. Those kinds of technologies became more and more feasible to move from abstraction to reality as computers became bigger, faster, and very powerful in a variety of ways. And therefore, the ability of artificial intelligence to move from narrow tasks to more general tasks is going ahead by leaps and bounds. And there are, of course, many schools of thought. Those who talk about artificial general intelligence and taking over the control of human societies or substituting entirely for human tasks which include abstractions, poetry, literature, and so on as unlikely, and the other who say it's only a matter of time. And there are important conceptual debates on this, but the fact remains that the power of artificial intelligence has grown by leaps and bounds and are principally in the hands of big tech companies which have also similarly grown. Now that power, the question remains, is that supposedly fine to modestly regulate by governments? Are they regulatable at all by governments? Do you need new ways of looking at those kinds of regulation? And Wendy here is an expert. I was good fortune to have a discussion with her just before this lecture. This is a debate which will go on, and getting governments onto the table is important. But again, there are views that it's too late. The big tech companies already have a lead on this and they will dominate discussions. And the other is that no, things are actually regulatable. And there's a third view that this technology will soon move from being extraordinarily expensive, energy guzzling, and unlikely to be easily innovatively dealt with by lower and middle income countries to aspects which can actually be done differently in these contexts. So that whether that will be the case or not, we don't know. I will now go to discussing about where Indian science is in all this. And debates about Indian science typically go in the following way, in your living rooms or outside, is, wow, this happened today in America or in Britain or in China, and why can't we do it? We are in a big mess, we'll never catch up. Or, look at China, the way they did it, why can't we do it that way? Or why can't we do it the American way? And so on and so forth. All of them have one characteristic underlying theme, and that is, why can't we catch up? And if catching up is what you're interested in doing, then you will succeed at best at catching up. And you will have to then work on catching up again. So that's not the way by which one can address these kinds of issues. Not by getting shaken and stirred and worried about what this country is doing or someone else is doing, but asking whether what we're doing is okay and what we should do. Why is what India does important at all for anyone? It's because we are the most populous country in the world, and our median population is very young in age, just as the median population of all of Africa is. So India and Africa have an enormous responsibility to address the kinds of questions I've said. And the question then is, do they have the capability to address it? And if they don't have the capability, how can we develop the capability and what is required for developing such capabilities? In a challenging and changing world, how can science deliver for India? How can we build this kind of capability? Now, science in India grew, current science, contemporary science, grew in an interesting manner. You had small colleges and universities set up during the colonial period by various methods, either by the British or by people who wanted to throw the British out, or people who wanted to save India in some other way, and so on and so forth. And these were distributed modestly all over the country in the presidencies, Delhi, Bombay, Calcutta, and small colleges in, for example, Ernakulam or, in Orissa or wherever. One of the geniuses who came out from such a system was Srinivasa Ramanujan, and he typified that period where individual scientists working hard, reading up in some manner, mildly or intensely, aware of what is going on elsewhere in the world, Ramanujan, Bose, Meghnad Saha, a few others, who by dint of their sheer ability and hard work did brilliantly. So it was an individual and not an institutional derived context. Some of these individuals, for example, Meghnad Saha, Jagdish Bose, they also decided that while they were great people, they were great scientists, that institution building was important. And these were the people who heralded Indian science moving from this college university era, where the bulk of the work was to train civil servants for Britain and then later for India, for British India and then for India. And science and mathematics was a side activity because it's one of those subjects which you're supposed to do well if you are to be a complete gentleman. And some people then, Bose for example, Meghnad Saha, moved by starting institutions. Bose started what became the Bose Institute, and Meghnad Saha inspired many to start the Saha Institute much later. And Shanti Swarup Bhatnagar, another scientist, started the Council for Scientific and Industrial Research. Now the CSIR is interesting, and when I use CSIR here, I use it as a proxy for multiple national institutions which came about at that time. The CSIR, the Indian Agricultural Research Institutes, the Defense R&D Laboratories, the Indian Council for Medical Research, the Department of Atomic Energy came much later, and the Department of Space came even later. These kinds of institutions were national, and the CSIR at its earliest days exemplified, and the Indian Agricultural Research Institutes exemplified a very interesting view of India, which was a view of India which was disconnected in many ways from the large mass of India, but was focused on getting science and technology focused on getting science and technology for a national purpose. So you had, for example, a Camel Research Institute at the IIRI. You had a Buffalo Research Institute. In the CSIR, you had a Cement Research Institute or a Road Research Institute or a Leather Research Institute. One institute of each kind was enough to deal with the problem after which the institute was named for the entire country. Now that's an interesting model, but it reflects a rather narrow connectivity with a broad topic, right? Many people accuse the growth of such institutions as diminishing in some manner the university system. But that may not be entirely correct. The university system made huge efforts to succeed in that prediction of diminishing and managed to do that very well. Yet others have alleged that institutions like the CSIR were good at the cost of the university system declining. You've got a zero-sum game of funds, and therefore more goes here and less goes there. There was a late friend of mine, Bharat Chattu, who was in our CSIR lab, the CCMB, and he moved to the MS University, Baroda. And when I asked Bharat one day, why is it that our national labs are so good and the universities are not that good? And he said, well, why do you say that? That there's no shortage of bad national labs too. The problem is more challenging, therefore. One cannot say you're good by comparing yourself to your immediate environments. What is your benchmark? In science, it should be a global benchmark, right? If you therefore say that I'm good because someone else next door is not as good, then you're setting very low benchmarks. So, our national labs have done well if you look at it by looking at examples of success. This is the Saras aircraft, the Tejas, and so on. But the challenge in the national lab system is the following. The numerator, i.e. what you've done well, are examples of where you've succeeded. You point to this and that and say you've done so well. And that's true, and that's commendable, and it's absolutely fantastic. But the problem a finance minister has is the denominator. The problem people have is the denominator. Every year you're putting in a certain sum of money. That is a guarantee. Your success in science is not a guarantee. It's a chance, it's complicated. But what is a guarantee is that you get a certain amount each year, and your expectation from people is increasing every year. So your denominator is going up, your numerator is very small, and therefore when people look at these organizations as a whole, they say, they're right in saying, questioning, what have you done for what I've put in? And these organizations are right in saying, I've done all these wonderful things. But, a little bit of delay and a little more money, just wait on a little bit, and the world will be great. Now, that was fine as a 20th century philosophy. Today, the world, as I said, is in a crisis, and the question is that approach feasible? When money is short, do we need to look at things in a new way? Now, if developing capability, for example, if you are interested in defense, you would capabilities to be of a certain kind. What chance do we have in a reasonable time frame doing what we are doing now, the way we are doing it now, with the kinds of resources and capabilities and competence and comprehension that we have now, to have indigenous defense capabilities of a certain kind, not to cause war, but as a deterrent. Supposing that is your goal, what chance do you have of achieving it the way you're doing it now? And one will have to be frank and say very little. You'll have to have new ways of looking at it, particularly because the spectrum of possibilities have also changed enormously. And this is just for defense, but the same holds for jobs for people, for health, for agriculture, and so on and so forth. What does one do? So if capability is the goal, what is the route we have to relatively rapidly, or at least in a reasonable time frame, to get that capability? And for that, you need a broad-based competence. But you also need comprehension. It's possible to import technologies, import methods, import processes, and do all the right things and have enormous competence. That enormous competence you can see if you go to just outskirts of Bangalore, or you go to the Agricultural University campus where our labs are, you will see fantastic termite hills. That's extraordinary competence in air conditioning, right? But there's no comprehension. Termites don't know what they're doing. So we can copy technology and have great competence, and we can partner and have competence, but we need to also have comprehension in developing technologies and solutions. So that's a big challenge. Comprehension cannot come about without creativity. You need to have creativity, and for creativity, we need to both focus on real practical problems, but also at the same time, and this is a big challenge, focus on allowing creativity to flourish. And they seem antithetical. Creativity requires support without question, and addressing current problems requires very focused support with focused solutions. All of this needs to be done on scale. There's no point doing it well in your little backyard and having nice organic farming and a good solar roof and being sustainable and proving, look, I've done it. Those days are gone. Today we need this capacity on large scale. And how does one possibly do that? Now there are examples from Indian science where this was done against enormous odds. And it's puzzling to see how this was done despite enormous odds. Here's Dr. Ramarao on the right with Yusuf Hamid on the left of CIPLA. Ramarao was at the National Chemical Laboratories and the Institute for Chemical Technology later on at Hyderabad. And he took a drug which was available for HIV/AIDS and had a new process to make it and made that extraordinarily inexpensive, gave it to Yusuf Hamid of CIPLA, who saved literally millions and millions of lives in Africa and all over the world, right? This was extraordinary innovation. People sniff at that and says, oh, he knew the end product, he just made a new process. Good, that's it, but try doing it yourself. It's not easy. Try jumping with a solution, catching someone, a pharma company, and getting it, and the pharma company needs to have the daring to get this done. Not easy. Comprehension on what to do for science and society. Homi Bhabha is another interesting example. And while he's well known for setting up India's nuclear power and nuclear sector in a big way, he also set up the Tata Institute of Fundamental Research to have a situation where there's a major fundamental research exploration which allows the best of science and technology to be created and absorbed from all over the world, so that critical sectors such as the nuclear sector and other applied sectors can benefit from the creativity which is there all over the world. And that creativity comes from nurturing originality, from having both hard work as well as inspiration by interacting with the whole world, have an openness to interaction. It doesn't come by hunkering down and doing things. You have to have enough time for tea and chatting and relaxing and thinking. And most of all, and most important, and this is counterintuitive, you need to be able to spend a significant amount of resources for things which are obviously useless. If you don't do this, everything else goes for a toss. You will be a termite-hill. And this is something which we are unable to talk to people. Scientists are very bad at conveying this. But if you don't have the time and effort to learn about mathematics, music, dancing, and chemistry and biology in a way which is really not purpose-driven, you are not going to succeed in solving all these problems. And we need to do this in a country this size. So it is important to feed our people. It's important to get them out of poverty. But it's also important to give them the time, the space, and the luxury, which we think is the luxury, of being able to dance and think and sing and do mathematics. That should also be added in a sustainable development goal as critical. And we are not doing that sufficiently. What we have done is something interesting in terms of building capacity. I'll go through this rather fast. We have got, you also have to deal, it's not just good to understand technology, you have to be able to market it. It's a competitive world. We need resources, you need rare earths, you need minerals, you need to balance what you do there with environmental degradation. So you can't have renewable energy and degrade the environment while mining. And there are risks and uncertainties. Scientists are willing to take risks, But day-to-day uncertainties are huge in our lives in India, and unless India learns to not have those uncertainties, scientists will not be taking risks sufficiently, and they conflate risks and uncertainties. The availability of power or water and so on is an uncertainty, it's not a risk in your entrepreneurial venture. We also need to have major projects which are taken up, and ISRO is a good example which has taken up these kinds of projects. Again, new challenges today, which we see with new approaches to space and space exploration, require ISRO to pivot, and ISRO is doing that. I don't have time to get into that. And India has also put in place several big science missions which have their strengths, limitations, opportunities, and threats. And I will not spend too much time on that, but these are the kinds of science, big science explorations. And again, many of them, what practical use is a laser interferometric gravitational observatory, a 30-meter telescope, a quantum mission, a deep ocean mission? These build science and technological capability, but unless they have a deeper connect with our societies and unless they are benchmarked at the best international level, they have the danger of sinking into a me too, I've already done that. So this is the LIGO. There's a huge Indian laser interferometer gravitational observatory coming up in Maharashtra, and that will be at the cutting edge of vacuum technology and laser technology. There's also, many years ago, India, Govind Swarup started the giant meter wave radio telescope, which is again completely designed and made in India, which is functioning. It's a really top quality radio telescope, and that's an example of how that helped Indian industry in these sectors grow. There's a major quantum mission which is going on now, and I'll discuss that later on if you have time, a deep ocean mission, and so on. Now, good, so you have all these exciting high-tech things happening. You have, all sorts of challenges in the world. How are we going to link India's capacity, potential capacity, to address global issues? The fundamental secret, which I haven't told you so far, is 90% of our research support, including space, atomic energy, everything, 90% of our students go to. 90% of our students go to places where there's no research support or very marginal research support. There are new ventures which are ostensibly are going to try to address this. They are very powerful methods, and if successful, they will be transformative. One of them is the Anusandhan National Research Foundation, which aims to invert this situation. It's a long haul and requires a lot of resources and good management, and we should all wish it luck. But unless we have our science research being done in a wide way, part of it purposeless, part of it purposeful, we are not going to address these kinds of matters. We have got enormous capacity in a very narrow sector of our country. We need to broaden that footprint to the rest of the country. Let me end by giving you a distribution of our national laboratories, central and state universities. This is India. These are the laboratories of the Department of Science and Technology. These are the laboratories of the Department of Biotechnology. These are the laboratories of the Department of Agricultural Research and Extension, of the Department of Health Research. These are the Defense R&D labs. These are the CSIR labs. Extraordinary capacity and capability. All of them what I would call a short walk from India. These laboratories have taken brilliant young people, trained them well, and done extraordinarily well, all said and done. There are challenges, no doubt. But are they going to be effective in transforming India going forward and transforming the world, helping transform the world? Here are our central universities. Their research, there are about 75 of them. These are centrally funded. Their research support needs to be ramped up enormously. That's not easy. This number is nothing compared to our state universities. There's even less research happening there, right? You can always say, oh, but they're difficult to manage and so on and so forth, but, well, the whole country is difficult to manage. These are solvable problems if we address that. So, if we invert a situation where each of our national laboratories for each of these agencies are connected to our state universities and to our central universities hugely, then there's a potential for creativity to be unleashed. And that's the goal of the National Research Foundation, and that's what they would like to achieve. And whether that is achieved or not, it's a big challenge, but the attempt is a very important one, and let's see how that goes. So for capability, a path to success is enhancing the breadth of all of this. My last slide is one of Rodham Narasimha from Bangalore. He was the director of the National Aeronautics Laboratory, now the National Aerospace Laboratory, a professor at the Indian Institute of Science in Aeronautics, the head of the National Institute for Advanced Studies, and a professor at the JNC, a scholar in ancient Indian science, and an extraordinary fundamental researcher in turbulence and fluid mechanics, a fellow of the National Academy of Sciences of the USA, a fellow of the Royal Society, one of our most brilliant minds. And this one individual took on the task of shaping Indian aerospace, as well as doing brilliant fundamental research, as well as contemplating about important cultural issues. If in each of these places, in our state universities and our colleges, we could nurture in a 10-year period 10 such people or 100 such people, then we would have been able to not only transform India, but also transform the world. Thank you.
Thanks, Vijay, for this engaging talk, which has raised a significant number of questions for us to think about. I don't hope to, in the short time available, be able to do justice to many of these critical issues that you have highlighted. My purpose is to raise a few questions to you, which would probably would help trigger further thoughts about some small subset of what you have talked about. Perhaps I will begin because you began at a probably a global, or even what I could call a cosmic view, and to reach where the kind of tumultuous time we live through today. One particular phrase you used, and I would like to connect that to the question of Indian science later, which is about the issue of the neutrality of science. And neutrality of science in both understanding and perhaps contributing to where we are and where the solutions go. So an alternative view is that science is deeply implicated in not just generating solutions, but the problems also. Because science and the scientific enterprise is significantly connected to economic forces and the political forces, and both have a deep investment in influencing science and the way thinking about science happens. Would you talk about a little more about the neutrality, and then I would follow up with a more direct question to how it panned out in the Indian context. So to be very specific, what would be a response if all the various challenges that you outlined, could there be a world in which science could have been different, which didn't lead to these kind of challenges in exactly the same fashion we are facing them today?
Yeah, thank you. It's, in my view, not possible to be neutral. And this lack of neutrality perhaps started with the discovery of fire. Right? Is fire neutral? Is the wheel neutral? Is the axle neutral? Right? It's not. Science and technology is deeply embedded in society. Not that here's a scientist embedded in society, but they're all mixed up in multiple ways. So that kind of a neutrality is not there, and people don't worry about it typically, except when either in hindsight or with some foresight, really unusual events occur. One of them was America's decision to speed up the making of the atomic bomb in a letter which Leo Szilard persuaded Einstein and others to sign and sent to the President of the United States. These very same scientists, many of them, not all of them, after the bomb was dropped in Hiroshima and Nagasaki, and later on, became peaceniks against nuclear bombs. So you have that example. I gave you the example of the Haber-Bosch process, where it's completely transformed the world of agriculture. Half the nitrogen in each of us comes from the Haber-Bosch process. But, you know, it was also an instrument of making chemical weapons. So that's the fact, that's what happens. What would have happened in a counterfactual situation if you decided that if Enrico Fermi decided that his insights into fission or the others, experimentalists who wanted to make the bomb, decided not to make it, well, their argument was there. This argument was there. It was that if we don't do it, others will. And that pushes people into a non-neutral position.
I'm reminded of a very humorous line from Tom Lehrer about the impossibility of neutrality, where he says, once the rockets are up, who cares where's the calm down? That's not my department, says Werner von Braun. Right? So I'm linking that to the question of the Indian context. In many ways, India's post-independence scientific policy was perhaps a balancing act between the universalizing claims of science and the very specific contextual needs of a poor, impoverished, emerging post-colonial society. So you mentioned the question of what should the benchmarks be. Would you say that Indian science and scientists have arrived at a set of benchmarks, starting from the institutional growth of the of what you could call Nehruvian science, to arrive at certain benchmarks that are appropriate for this particular society? And where did we succeed and where did we fail?
You know, the standard response which scientists more or less legitimately give when asked this question is they shy away by saying your funding was inadequate, your rules were, oppressive, the uncertainties were high, and given all of that, we've actually done better than bureaucrats or politicians or economists or engineers and so on and so forth. Now, that's a bit of, while there's some merit in that argument, it's by and large, in my view, a cop-out. And it's a cop-out not because that I'm diminishing the difficulties which people face. Of course, we all face difficulties. But that's precisely the point, that given all the difficulties we have, could we have done a lot better? And in hindsight, yes, which is not to deprecate what's been done. But in hindsight, I think we could have done a lot better. And therefore, that's a lesson going forward. What could we have done? So, for example, if you take our medical research, it's been confined to, different kinds of approaches in epidemiology, for example, or in disease management, which have not scaled. They were very valid and valuable at a time in the 1960s or 50s when, access and technology were different and the population was much smaller. So we've not jumped up into new ways. Industry has actually embraced that enormously, and therefore there's an opportunity today linking, the computer industry and the discipline-oriented science domains in health or agriculture or wherever to look at both delivery and the analysis of problems and their solutions. And a lot of that is actually happening. So I'm optimistic that there's a potential for institutional structures, both the public structures and newly growing private ones, to rejig themselves with integrating new technologies into addressing the problems. But no, we have not addressed those problems sufficiently, though it's important to keep in mind, we have addressed them well compared to many other countries and even on an absolute scale. Our vaccination programs our maternal safety programs, our life expectancy at birth are dramatically different now from 1947. So we should not diss things just because we see difficulties in the way things are. If this were 1947, then most of us would be slightly dead.
So a quick follow-up on that. Post-independent scientists and scientific institutions had what you could call were on the right hand of political power. There was a sense of trust and faith in science and technology as a kind of potential source of solutions for India's problems. Now, especially in the case of technology or as applied to, let's say, poverty reduction or economic growth, it could be argued that the expectations didn't pan out. So do you, as someone who has been on both sides of the equation, as a scientist and also listening to decision makers and policy makers, do you see a certain erosion of that kind of trust and faith in the capability of science to solve India's problems?
No, I don't think there was a disproportionately high trust, even though we like to imagine the past in that rosy manner and say there was. And I don't think that there's a disproportionately low trust at present. Let me give you two examples. Homi Bhabha, when he set up the Tata Institute of Fundamental Research, complained that his chief, then there was a deputy director, is a Scotsman, Allardyce. He said Allardyce wouldn't allow him to serve biscuits after the colloquium because that was a waste of money. And Bhabha had to argue and said that if I were in Cambridge, I'd be serving wine and cheese. And so Bhabha was prevented from serving biscuits. I mean, I don't know who got their way, but that was a challenge. I met a very senior accounts officer in the Indian Account Service, now no more, who, when I said I was joining the Tata Institute for my PhD, said that, oh, I used to work with Homi Bhabha, fantastic man. Out of 12 major projects which he submitted, I managed to throw out 10 of them. So this was a success of the finance person that, how many projects can you turn down? Because money was limited and you had to filter things out. That continues to be the case, but it was no different then. Today, too, there are expectations, but those expectations reflect a different world. At that time, science was very different, and as I said, science today is very different. So the kinds of people who people in government interact with are technologists familiar with telecommunication, wireless, artificial intelligence, biotech, and it's a distributed system. It's no longer, a handful in space and so on. So that's the difference. But those who are there, it's not a question of having trust or not. Delivery is a challenge because the pot which has to be distributed is a zero-sum game. There are multiple huge demands on it, and that's always a problem. And it's a much, much bigger problem now.
So in this context, would it be right to say that the scientific institutions and scientists paid, because of the focus on the state as a source of sponsorship and funding, much less on the potential of Indian industry and economy to support science and perhaps even nurture scientific research? And was that a problem, or do you think that the scientific institutions tried their best?
Yeah, there has been a disconnect between the growth of industry, the needs of society, and the growth of scientific institutions. There's no doubt about that, and skirting around that doesn't help. But that said, the extraordinary growth of industry in many ways, capability in industry, the extraordinary competence and creativity in our scientific institutions, which there's a wall around that. If that wall can break, then dramatic change can happen. That kind of breaking of the wall is happening in certain sectors, in certain places. IIT Madras's research park is a tremendous example. That's happening in leaps and bounds. There are areas in biotech in Bangalore where that's happening. It's happening at IIT Delhi, in IIT Bombay. It needs to happen on a much larger scale. So the understanding of science at every level, that capability is immense in India, in every sector. The execution of that understanding into practice in a changing scientific world is a challenge, and the translation of that practice into industry is an even bigger challenge. These are challenges in Europe too. The kind of innovation and drive which you see in America is difficult to see in Europe, and Europe envies that, even though there is a lot of it happening in Europe now. So, but as I said again, this part of the 21st century is different, and it requires new approaches and new ways of dealing with it.
And that gives me a certain segue to come to the issues of capability that you talked about. But where, even with our limited resources or limited institutional capacity, the kind of development of capabilities manifested in individuals and people, would it be right to say that the Indian economy and society did not derive the full benefit of those capabilities? And in many ways, the reference group for those capabilities were the West. And it was to the West that many of these people were headed, right? And that, the so-called brain drain, what could Indian science have done to prevent that?
I think India was extraordinarily wise in not preventing a brain drain, right? It's not, I would not call it a brain drain. America is the principal beneficiary of that. And America's greatness in science and technology and many other aspects, despite what we see happening, America is a great place. That comes entirely from its welcoming of talent from all over the world. That's the American ethos. The British ethos is to have tea 2 times a day, think hard, and get much more for your buck than is possible, right? The Chinese ethos is different. The Russian ethos is different. We need to develop a way by which we introspect, look at what our moorings are, and see how we can do superb cutting-edge science. And that's feasible. There's sufficient amount of quality in the country which can address that, and it's been demonstrated in many areas, in public health, in IT, and now it should be demonstrable in other areas. Some areas are a very long haul and require a huge amount of money, and if it's a long haul, it's good to start now. If you want to make a passenger jet aircraft, then it's a long haul before you're a Boeing or a GE or a Rolls-Royce, right? It's not going to happen overnight. That requires huge investment, huge planning, huge capabilities development, and so on and so forth. But there are many other areas where the capability to bore through the mountain of excellence and go to the other side is something which is feasible. And that's the beauty of science.
So that feasibility, it has been said that India's problem of converting potential to capability, as you put it, faces an infinite regress. Where do you mentioned the problem that the perhaps misdirected investment at the very small minority of top-level institutions, perhaps a certain neglect of mid-tier and third-tier colleges and universities. But then we can mention that the school education system itself is not oriented towards questioning or doubt, which is at the core of the scientific enterprise. It is more oriented towards a certain kind of repetition of truths passed down. I'm caricaturing a bit. Now, given this complexity, right, how do we place the fundamental educational question of developing capabilities, and how do we make it tractable? You outlined the core critical anchors of that capability, but what makes it tractable, and what is tractability there?
It becomes intractable if we dwell on stating the problem and then, as the next step, trying to boil the ocean. And then there's trouble there. You're not going to solve problems by always stating that someone else, the central government or someone, should solve it. We have to find a way by which a combination of bottom-up and top-down disinhibition allows things to happen. That's happened in some sectors, so that's exemplary. The question is, can it happen in education and research? And that really requires putting into practice what, for example, the new national education policy says it should do, which is to disinhibit the functioning of our university system. If that can happen, if our national laboratories can open up, if our school system is made unfettered, if industry works to help and participate with skilling and provide jobs. I think these are all a combination of top-down, industry-led, skilling sector-led, state government-led initiatives. And they cannot be orchestrated. And the question is that can they be enabled? It's a tough one. India does really well in two things: in solving a crisis and creating a crisis. It's tough in terms of our attitude to work towards preventing a crisis. It's just not easy. We have so many problems that it's not easy. That's why, what you're saying is that we seem to snatch defeat from the jaws of victory again and again. But we have, gone ahead in many ways. And it's gone ahead because of the bottom-up pressure of people who want jobs, who want to fulfill their aspirations. And therefore, if reagents are available for them, I think that's a solution rather than a top-down one.
So, in this process of
being waved to.
Yeah, so last, perhaps one more question to wrap it up. This particular educational challenge of expanding the possibility of science and scientific thinking through education. One is the role of scientists and the scientific establishment in reaching out to a broader society. The cultural interface of science, which arguably has been rather weak. Indian scientists, it could be argued, that have really not reached out to the public the way, for example, in the US or in the West. The public communication is a central aspect of the scientific enterprise. And that, would you see that, and also a certain resurgence of anti-science in the public at large, in some way connected? And what is it that can be done to counter everything in your own field, in biology, in medicine, in biotechnology, and the interface of that with the state and the political processes? That's a vexed issue. I don't expect you to be able to outline all of that right now. But can you say something about that?
No, that's all of these are critically important. That there is no communication or poor communication between scientists in India and our societies is a deep problem and comes from a rather deep lack of connect with the science we are doing with social purpose of various kinds. It's not that it's completely absent, but it needs to be hugely more organic. The problem with it becoming organic is it becomes messy, right? Scientists if you want to create a space where excellence thrives, then the first thing scientists do or institutions do is to create walls, right? That allows the building of excellence. But while that arguably is something which you need to build that kind of an institutional excellence, you need to ruthlessly break those walls and connect with society at some point. In my view, Indian science has developed really well in creating multiple islands all over the country of excellence. But now it needs to break those walls and connect much better, more organically. And that's feasible. So that's not a real problem, whether we will do that or not, but the feasibility certainly is there. Problem is, talking about politics and industry and science, in a very sort of intense, heightened and stressed out democratic system, politicians want results every Friday evening. Industry wants results every quarter, and scientists say that they'll give results every century. So there is a there's an impedance mismatch here, so communication is very important.
This brings us to a close of this session and this evening's program. Thank you all. Good evening.